Number 17, dealing with an absolute value equation where we have an equal sign. So we have the absolute value minus 3, all this equaling 9. First thing we want to do is try and get the absolute value piece isolated by itself. So we're going to need to move this minus 3 over before we do anything. Excuse me. So we're looking for the n plus 1 to come out to be a value of how much? 12. Because 12, the absolute value of 12 minus 3 will equal 9. Or, you could have a negative 12 in there too. That's right. This is where what we're doing is absolute value is how far away from 0 you happen to be. Well, 12 is 12 units away, but also is negative 12. So we have to look at both solutions. So, hey, we're going to set that n plus 1. It could be a positive 12, but what else could be inside here? It could be a negative 12 in there because the absolute value of negative 12 is 12. So we're looking at where it's positive 12 or negative 12. That's how we always do these problems. Subtract 1, subtract 1. One possibility is 11. The other possibility, negative 13. Okay, negative 13. Negative 13 plus 1 is negative 12, but the absolute value of negative 12 is positive 12. And positive 12 minus 3 gives you 9. 11 will also work. 11 plus 1 is 12. Absolute value of 12, 12. Take away 3, 9. Here, again, we want to get the absolute value piece by itself first before we do anything. So it's being multiplied by negative 5. So we're going to divide by negative 5. We're going to get, hey, the absolute value of n plus 4 equaling 3. We now break it into its parts. N plus 4 is equal to the positive 3, but what else could it be? It could be equal to a negative 3. Those are our possibilities. And again, this is always an or. Subtract 4, subtract 4. N could be negative 1. The other possibility, n could be negative 7. So our solutions, n equals negative 1 or n is negative 7. Now this guy, when we see an n on the other side, we're going to end up with a solution that probably doesn't work, an extraneous solution. So the way we do this is we say, hey, n plus 2 could equal that positive 3n minus 10, or it could equal the what? The negative piece, the negative part. Remember, when you do it, you must put it in parentheses. This is an or. So now let's solve this one. Well, we'll just move our n over first. We'll subtract n from both sides. Sometimes y'all like to move the variable to the left, but it doesn't matter. We subtract n. We end up with, that goes away, 2 equals 2n minus 10. Now let's move our number to be over on that side with him. And then divide by 2. N is equal to 6. That's one possibility. Over here, well, you need to distribute your negative 3 through. And don't forget to distribute it through to the 10. Now we're going to have to solve this guy for n. Well, let's move the 3n over, the negative 3n. So I'm going to add 3n to both sides. I get 4n plus the number 2 equals, that went away, 10. I now subtract 2. 4n is equal to 8. Divide by 4. And you're going to get a solution of 2. So we got 2 or 6. However, will they make it true? One of them probably will, one won't. Let's try the 6. If I put a 6 in right here, what's 6 plus 2? 8. Absolute value of 8? 8. But will we get 8 over here? 3 times 6 is 18. 18 minus 10 is 8. Yes, this guy works. Yes. What about 2, though? Okay, what about 2? Well, let's erase this right in. Oops, that didn't erase too well, did it? Let's hit Mr. Eraser. There, much better. And let's plug our values back in. If we can get it to work here, okay, we're going to plug 2 back in. 2 plus 2 is 4, right? 2 plus 2 is 4. Absolute value of 4 is 4. But here, 3 times 2 is 6. And does 6 minus 10 give you 4? No, it gives you negative 4. This solution doesn't work. So the only true solution is n equals 6. And that's the only one you put on your paper. Okay, that 2 didn't work out.